Hello, I'm Corey Graham. This is our project, the speaker galvanometer. So what it does is, this is what it is, and what it does is we can angle a laser at two mirrors, and determining the angle of the mirror, we can give it a precise location, as described in this. So one lens does the x-axis, and the other does the y-axis. And this is called a galvanometer, which, if you don't know what a galvanometer is, it's kind of like this ammeter right here. It basically depends on how much voltage it receives. It will change the location. So according to this code, the code we have is it multiplies the angle times the voltage, not the angle, but the meter, or I can't think what it's called. The voltage times 5, and then this will give it a 0 voltage, and so it'll have a precise angle, but probably down here somewhere. And it has what else? And for the circuit board, we had to put resistors in here, and they're just these ones are twice as much as these ones, and so these ones are 1K and these are 5K, 0.5.
Okay, so the system we used to get our output to the speakers was called an R2R resistor ladder, or an R2R digital analog converter. And this is the schematic for how these are made. We have a resistor of one value, and then parallel to it we have a resistor of twice the value. And we have this series of, it becomes essentially a series of voltage dividers. And about half the current comes through this one, 25% through this one, 12.5% through this one, and each one is halved. So if we have all of these bits on, we have about 4.8 volts. If all of them are off, we have 0 volts. So we have 255 steps, and that number is because we're having an 8-bit binary output from our microprocessor. So our microprocessor outputs 8 bits, so we have anywhere from 0 to 255 different steps between 0 and 5 volts. And we put those outputs through a circuit we made here with some transistors for current amplification, and that goes directly into the speakers. And a speaker works by changing the voltage on the speaker will change the position of the diaphragm. By giving a direct current, it will change the position of the diaphragm to a specific location that it will not change. So we're using this digital to analog converter to change this voltage to a certain position, and that will therefore change the diaphragm. And because we have a mirror hooked up to the diaphragm, that will change the angle of the mirror, and will therefore change the position of our laser up here. So if we power this on, watch this laser up here, we'll see it start to move.
Do you want me to speed it up anymore on the...
Alright, so we noticed here that because of the way the transistors work, we were getting not enough current amplification, because depending on the voltage we put into the transistors, it'll amplify a different amount of current. So depending on the voltage that we're putting through it, the current will be at 2 volts around 14, at 3 volts around 22, so it's a non-linear relationship between voltage and current, and that means we're having a non-linear position for our galvanometer. It's not as linear and precise as we thought it would be. So in future projects we are planning on doing a smaller, instead of a large solenoid, which is what a speaker is, we're going to be using a smaller solenoid, which will use much less current and voltage, and therefore have less power that we need to drive these speakers with. So that's our project.